Civil engineering surrounds us. You've probably driven in a car before, and when you're in that car, you can probably see examples of two kinds of civil engineering I'm going to discuss in this presentation. The first is bridges, structures, and the other is architectural engineering. Bridges are a way to get across an obstacle in a practical and impressive way. Bridges are an integral part of the modern roadway, and the two kinds I'm going to go over are suspension and arch bridges. These are the two basic kinds that I'm going to present on. They may not be the kinds you're used to seeing every day, but they're a lot more interesting than the flat bridges with one pylon. Suspension bridges rely on tension to support themselves. Usually have one or two middle posts that have cables running off of it, and they're held in tension to keep the bridge upright. This is a really secure way to hold a bridge but let it flex. There's a saying in engineering that you can't push a rope. This is the concept of not being able to put tension into a rope that pushes holding a structure upright because it'll fold and fall. It's the same thing with the cables on the Golden Gate Bridge or in the diagram. Arch bridges depend on the rigidity of the building material to keep their structural integrity. They anchor on the points and have a rigid material that pushes all together to create that arch shape. In an article on bridges, the author states, "The arch bridge carries loads primarily by compression, which exerts on the foundation both vertical and horizontal forces." Another factor of bridge building is lateral thrust. This is in the arch bridge and less in the tension bridge, but it is the force that is applied, the weight, as it's distributed outward, it pushes on the anchor points of the bridge. Right, like this. So we have force pushing on each of the anchor points and you distributing the weight of the bridge to the 2 points rather than here in the middle. This concept mostly obviously applies to arch bridges. As I said, tension bridges, it doesn't affect it as much. Architectural engineering is another aspect of civil engineering that differs immensely from bridges. A civil engineer that is an architect, its job is to design something that is structurally sound but also appealing. You don't want an ugly building. A good example of this is the Sydney Opera House or the Disney Concert Hall. Sydney Opera House and the Concert Hall. These both are built in a very modern style with lots of angles and curves. These are particularly difficult to design because of the many forces playing a part in the balance and integrity of the structure. You also have to take into account the winds around it and the aerodynamics of the structure you're building. Another structure that is common is the tower. The Eiffel Tower is one of the most iconic towers in history, besides maybe the Tower of Pisa, but that one isn't structurally sound. The Eiffel Tower is built of a steel girder system that has a semi-large basis of support. You can see it doesn't have a lot of weight at the top and goes outward at the bottom for a strong basis of support. Its cousin in the US, the Seattle Space Needle, is a great example of structural expertise where they didn't use just a little bit of weight at the top. They had equal amounts of weight at the top and the bottom. The small solid base, aided by the breathability of the structure, is what keeps it upright. There's also aerodynamics that goes into the observation deck at the top to keep the wind resistance down and keep the forces pushing it over to a minimum. In conclusion, I think we should all go out of our way to appreciate the engineering that goes into the everyday things we see around us, the buildings and everything, not just the civil engineering, but also the mechanical engineering. But